In this video, we will discuss an overview and an introduction to the field of information technology. Information technology can be defined as the way information moves, gets managed, gets secured, and gets supported in a business, an organization, or even at your house. These days, every company uses a computer in one way or another. Even the Amish probably use a cash register and probably take credit cards, meaning they are transmitting credit card information over wires and communicating with credit card servers, probably on the internet. I ask the question sometimes in my class, is there a profession that does not use a computer? One answer that I got was lifeguard, which is probably a pretty good answer. Unless you're wearing a waterproof digital dive watch, maybe you don't use a computer. Even though IT uses technology to a great extent, we are still a people business. We still deal with people. We still have concerns about communicating on their level, on understanding their perspective, on helping them understand what we are doing and helping them make decisions. Therefore, let's always keep people at the center of what we do, and let's always be training ourselves to work with people and get better at that aspect of our job. Because we know from experience, IT people usually don't make the best communicators, especially when communicating with other people. Let's work to improve that all the time. This is my list of how humans use information. And since IT has information in it, it's important to classify the uses. Decision support is a spreadsheet, a simulation, some information that helps people decide whether to bring on more employees or shut down a plant or introduce a new product or even turn the video game on and off. Entertainment is software because all movies and songs and games are digital. They are software. So information technology provides us with entertainment. Documentation is important because receipts are transmitted online, deeds and contracts are collaborated with and signed and registered online. All of those things are stored in the form of digital documents. So information technology must be able to manage those documents. Control. Almost everything has a computer in it these days. Your car, your pacemaker, other embedded surgical medical appliances. Information technology is used to manage the information that moves through those things and is used to create those things. Education. All of us have been educated, or we are being educated right now, through information provided electronically. We take tests online. We use training courses provided over the internet, and we look at demonstrations as well. I see these then as the 5 broad categories of the ways that we use information. Here is another list of mine. This is not a complete list by any means, but it is a broad overview of information technology topics that are currently in demand and currently actively being sought after, researched, improved, developed. And these could be career paths, these could be fields of study, these could be research opportunities. But I have found these to be interesting things that IT people study. Security, I think without question, is the most talked about, most popular in our culture aspect of IT. A lot of people want to be the one to catch the bad guys, to do penetration testing, to break into companies with the permission of the company president, to steal secrets with the permission of the security officer of the company. We like to read those stories. We like to watch TV shows about hackers and counterintelligence operatives and spies. Certainly, our data is at risk. Our computers are at risk. The Internet of Things is at risk. On the screen, there's a reference to the Target data breach, which in reality started when a vendor working for Target was hacked, and that vendor had on file credentials for the Target network. So Target themselves, strictly speaking, were not hacked, but they gave up their credentials indirectly through a third party, and the eventual result of that was software being installed surreptitiously on Target cash registers to harvest credit card information. Everybody wants to be the person to do forensic analysis on that cash register and to hunt down those bad guys and bring them to justice. Security certainly is an important aspect of IT. Another important aspect of IT is a huge, tremendously overwhelming proliferation of data. We are gathering so much data that is impossible to process. Humans cannot comprehend the amount of data that we are generating. Somebody has to manage that data and make it consumable. Somebody has to make it into infographics, store it in databases, retrieve it appropriately and in a useful fashion. And managing that big data, visualizing that big data, are career paths that IT people can follow. This is interesting because you don't have to be a traditional programmer type to do work with big data. You can be a data analyst, a database manager, or you can stay at the other end of the data and do visualizations and provide those tools and those results for customers and employers. On the slide is a classic example of a bad data visualization where we attempt to correlate Internet Explorer usage versus murder rate. We're charting on an XY graph the decline of Internet Explorer usage and the decline of murder rate. The implication is that the Internet Explorer decline has something to do with the murder rate decline because we put them both on the same graph. Obviously ridiculous, but a very good example of how easy it is to cobble together a bad data visualization tool. Virtualization means that we can run a computer inside of another computer. For example, we can run multiple instances of Windows 10 on one large PC or one large server so that multiple people can be running their desktops inside of the same physical platform. This is a tremendous time saver, a tremendous resource saver, and money saver for businesses. And in the future, you will find that you will not have a desktop computer at work. You will have a very simple client, typically just a browser, on your desk or on your laptop, and your computer will be virtualized somewhere on the internet or somewhere on your company's intranet, therefore making management of that desktop much easier and much more secure. So somebody in the IT field has to create those virtual machines, group them together, and manage them in a secure and convenient fashion for all of the people that need access to that hardware and software platform. That could be you. Cloud computing. Well, we've all heard the word cloud. We all know that we can blame everything on the cloud. We all know that we can store things in the cloud. Our phone photos are stored in the cloud. Our email is stored in the cloud. Eventually, As I said, your desktop will consist of nothing but a client, and all of your information will be stored in the cloud because it is so much more convenient and so much safer and actually so much cheaper too in the long run. IT people have to manage that cloud. IT people configure it, secure it, set it up for all the users, extend it, expand it, look for new ways to improve it. Again, another career path in information technology. Software development crosses all of these career paths. It overlaps security, it overlaps big data, overlaps virtualization, cloud computing, everything we will talk about here. We will always need programmers. We will always need someone to learn that new programming language and implement those wonderful new features and new applications. We will always need people to manage legacy systems and learn that old programming language that nobody teaches in college anymore, but you can make a very good living at. And I will say from my experience, if you don't plan to be a programmer, you still need to learn some programming, because any of these career paths will find you looking down the barrel at a macro or a short little program or a script that you will need to write, and you will be sorry if you have avoided programming like the plague. So take the time, dip your toe in the water, learn some programming, even if you don't think you will be a career programmer. Networking. Somebody has to manage that network. Somebody has to control the flow of information through the internet, through the router in your basement, through the wireless router your phone connects to. Somebody has to write that software. Somebody has to design those algorithms. Somebody has to implement the security. Somebody has to understand TCP/IP and make sure that it's available to everyone. Networking, a tremendous growth opportunity in information technology. One of those things you can a lot of times do at home in your pajamas. Mobile computing, another growing field. We're adding millions and millions of devices that connect wirelessly every year. Wireless networks are not secure. We need somebody to program those wireless networks, to maintain, configure, secure those wireless networks. We need somebody to install, test, configure, and design all the new applications for mobile devices. Who knows what kind of device Apple will introduce tomorrow? Perhaps a wireless earring that needs to be programmed and tested. That could be you. That could be the iApple earring. Embedded systems, also Internet of Things. Everything computes these days. Almost everything has a chip in it. Your dog's collar has a chip in it. The pop machine has a chip in it. Your embedded medical devices are communicating with the outside world via radio frequency and Bluetooth near-field communications. Your car has numerous computers in it. The next time you visit a vending machine, do me a favor, look around behind it. Chances are that vending machine is connected to the internet through an Ethernet cable plugged into the wall. Everything has a computer. All these devices need IT professionals to keep them going. DevOps, development operations. Our code base has grown so huge and so dynamic that there are career paths dedicated just to managing the volume of software being developed. Somebody has to understand how to merge the next set of revisions into the existing product. Somebody has to understand why the developers are upset because they can't get a release to go through the system even though they're under a deadline. Somebody has to understand why we need 10 versions of the same program because there are 10 different CPUs out there that need to be optimized. Somebody has to work with development teams across the world, diverse communities, different time zones, different cultures, all wanting to contribute to the same code base, all wanting to achieve the same end, but all having their fingers in that development pie at the same time. So DevOps is a huge growth opportunity in IT. Project management, these people probably get the most abuse of anybody in the IT field. Someone has to tell the boss the program is not on schedule, that the project is behind, it needs more money, it's not going to come in under budget. Someone has to negotiate between DevOps and development when they're banging heads together on a Sunday evening to try to get the next release out. Somebody has to manage that Gantt chart so that everybody else on the project can see whether we are ahead or behind or what the next milestone is. Project managers are the unsung heroes of IT, and probably out of this list that I've given you of IT fields, probably the profession that requires the least amount of programming per se. If you don't want to do any kind of programming at all and you're just trying to avoid it like any way you can, a project manager position might be for you. It's probably the most people-oriented of the IT jobs. So you're going to take the most abuse from other human beings, and you have the least amount of control, but a lot of times the most responsibility, because you're the one that gets to tell everyone else that they need to pick up the pace or reduce their budget. All right, let's shift gears a little bit. One question I get asked is, what is the difference between computer science and information technology, particularly when you are trying to choose a major or considering a transfer? Computer science in a nutshell is theory and math. Now, I will tell you, and if you want to get into a great argument on Reddit, go into a subreddit and post a message that says something like, programming is math, software development is math. You will get downvoted and beaten to death, even though it's 100% true. Programming is math. That's because logic is math, set theory is math, algebra is math. They don't want to admit it, but if you're doing programming, you're doing math. Anyway, back to the topic at hand. Computer science is theory and math. You will be thrown into Calculus 1 first semester freshman year in computer science. In IT, you apply the theory that the computer scientists develop and perfect, and you apply the math that the computer scientists have already learned. There's generally much less math in IT. There's generally much less math in the jobs that IT professionals have. But I will also tell you that generally grads from these two degree programs apply for the same kinds of jobs in a lot of cases. Again, I'm generalizing here. There are some engineering jobs that require a knowledge of calculus, of PID loops, of process control that IT majors might struggle with. However, there are some jobs that require use of tools, software development, that computer science students have not yet seen, because an IT grad is going to have a more hands-on experience in their time in college than a computer science student will. Again, I will generalize, and I will assert that an IT student straight out of college is going to be more productive faster than a computer science student will be, because the computer science student has spent more time learning theory and the IT student has spent more time doing hands-on stuff. That doesn't mean one is better than the other. That doesn't mean one is preferable to the other. I'm just telling you that in my experience, that is generally what happens. A computer science grad will probably get a job doing applications of what they've learned. An IT grad will probably get a job doing applications as well. There is not a lot of demand for theory jobs. There are not a lot of companies wanting to hire you to develop a new sorting algorithm. They want to hire you to implement and use existing algorithms to solve problems and create products that can be sold to generate revenue. Therefore, the CS students are generally looking for hands-on jobs, just like the IT students are looking for hands-on jobs. Again, my opinions and my experience in these fields. Thank you.